So moving on, we now have variables under our radicals. So what you should see there is I put the formula that you want to kind of keep in mind, unless you want to factor it. I'm not going to factor it. I'm going to show you this way. Just kind of is a little quicker and kind of can see kind of more patterns here. So looking at this formula, we have our x squared plus 14x plus 49. So I'm immediately looking here, right? 49, that is 7 squared. So we know our b is 7. Now, putting it there, we're going to divide this by 7. That leaves us with 2, right? So when we divide by 7 times the 2, then we're left with our a being x, right? So if our a is x and our b is 7, we're going to plug it into here. This should equal x plus 7 squared. Okay, so putting that under the radical, okay, we're going to keep that kind of thing that we've done before, just written out. Okay, we need to find our pairs, right? It just happens that our pair is an equation. So taking that out, we're left with x plus 7. However, when you have a variable as your radical simplification, right, you need to put absolute values because x can be anything. However, it needs to be positive, right? Or it's not going to be, a positive under the radical, right? All right, moving on, number 12. Well, from here, my strategy here is let's write this out, right? Oh, wait, look. Now we have a double, or a pair, right, of x plus 3. That just happens just to be right is here, right? Because this cancels out. If you remember, this is the same thing as power, right? And 2 times 1/2 is 1. So that's where you're left with x plus 3. All right, moving on to 13. We have 49 times x squared, right? Well, I already know 49 is 7 times 7, so I'm going to take that out already. I'm left with x squared, okay? Similar to what we had over here in 12, right? That's just going to cancel out to just 7x, right? Because I can just take that x out. So then we're left with 7x. All right, 14. Number 14, we have the cube root of 64. So this is another one you can kind of keep this in mind, or you could do the factor tree. So basically what you're going to find here is that 4 times 4 times 4 equals 64. So we're going to pull that group of 3 out because remember, if it's a 3, we need to find a group of 3. If it's a 2, you need to find a pair. So when we do that, we get just 4. All right, number 15. Number 15, another equation, right? So I'm going to think about it in our formula, right? We need to find our a and our b. Well, my square root over here, my b, what's squared is 64? 8, right? So we know our b is 8. Okay, moving on to here. When we divide by 8 here, we're left with 2. So we now know our a is x. Right? So similar to before, we're going to plug it in to a plus b, right? So that's x plus 8 and squared, right? So similar to the one before, when we put that under the radical, we're going to realize there's a pair of x plus 8. So that's where we're going to get our x plus 8. And remember, we got to put our absolute values. All right, number 16. So number 16 is very similar to number 11. You notice we both have 49 here. However, these have been changed. So let's look at that. So this is 7 squared still. So our b is 7, right? Let's divide 7 here. By doing that, we're left with 4. All right? Now, we don't have just x as a value anymore, right? Because we're left with 4x. So let's get that 2 out of the way. This is going to find our a, right? By doing that, we find our a is 2x. Now, we can check that, right? Because when we look at our 4x squared, 2x squared is 4x squared. So that's kind of your tell here, is you're noticing that number 16 is just 11, but with 2x instead of x. So from there, same pattern. Our a plus b, right, is going to be 2x plus 7, right, squared. Put it under the radical, find out that there's a pair of 2x plus 7. So our simplified version is just 2x plus 7. Oh, sorry, that's absolute value. All right, moving on to number 17. So number 17 is another cube root, and it's negative. Now, can a cube root be negative? Yes, because when you have a negative number times a negative number times a negative number, that does make it negative, right? So that's okay. However, it's a square root with negative, not good. So moving on from here, I kind of want to take out what I kind of already know. I do know, right? I do know that 5 squared is 25. Now I'm going to take a guess here. 25 times 5 is 125, right? So I can make this negative 5 times negative 5 times negative 5, right? Remember, we're going to make it negative because it's a negative 125. So from there, I found my group of 3. I'm taking it out. I'm left with just negative 5. All right, number 18. Another cube root. I'm already thinking about 10, right? Because 10 times 10 is 100, and 100 times 10 is 1,000. So I already know what's under there. So I'm going to put that under there, 10 times 10 times 10. Found my group of 3. Taking it out, I'm left with just 10. All right, same thing with 19. It's a cube root, right, with negative 1. So thinking that same thing, right, negative 1 times negative 1 times negative 1 will get us negative 1. So we just know this answer is just negative 1. When you see a 1, the root is always going to be probably the same thing under there. All right, number 20, our final one. I'm going to show you this method. It's a little different when you're trying to simplify radicals. This isn't just another method. I do this sometimes when I have really big numbers. You can separate these, right? That's still the same. These equal each other. So by doing that, I know the cube root of 27 is 3, right? Because 3 times 3 times 3 is 27. Okay, I'm left with our x to the third cube root, right? Now, similarly to number 12, right? It was a square root that had a root in there. Or it was a square root with a being squared, right? These match. So I can just take out x, because this is the same thing. Right? So, taking it out, I'm just left with 3x. Alright, so just again, I have a different way of doing it. Really, there's so many ways of simplifying radicals. The only thing you have to keep in mind is just making sure that you're keeping track of the factors that you're finding in your perfect squares. But other than that, as long as you're getting to the simplified version, that's all you need to do. So just use whatever makes more sense in your head.